Okay, this is in the middle of section 2.3. We had a question on this step, so I'll just go through everything, or at least the first part for this step. So from previous pages, we have 54 students that said Tim was on the left, 12 that said Bob was on the left. That gives us a total of 66 students total, and our sample proportion is 0.8182. Coming back to the applet, it says we're going to use our one proportion applet. Okay, if I go to the ISI applets, I go to the ISI applets, and I need to pick one proportion under categorical. Okay. And for the probability of success, if they're just randomly guessing, it should have been 0.5. Okay, so I'll put 0.5 in there. And we had 66 students, so we have 66 number of tosses. Okay. So now we're going to actually do the simulation. It said we want to do at least 1,000. I like to do 10,000, just makes me feel happier. And I can click draw samples. Okay. So here it gives me, these are the different values of the number of heads, or like the number of people that would have said Tim if they were just randomly guessing. So here's my different possible values. Let's see what it's asking us first. Okay. It says in the applet, put our class's sample proportion. So you could do number of heads as 54, or you can put the 54 in, and if you click proportion, it will change it to the proportion of our 0.8182. That was our sample proportion. And I can click count. Okay. And right here, it will show you if they were randomly guessing, we should have been centered about 0.5. Okay. And these are all the different possible sample proportions I could get. But what sample proportion did we get? We got 0.8182, this red number over here. Okay. And if you look, there were no samples that had a sample proportion that high when they were randomly guessing. Okay. So what proportion was as extreme as what we got? Like how many samples had a sample proportion that far away? It was actually 0. That is your p-value. So our estimated p-value is this red number right here. Is just like what proportion of samples were as far away as what you expected, from what you expected as your data. So our data, to get a sample proportion of like 0.8182 when the true proportion is really 0.5, that's almost impossible. There were no samples that were that far away. Okay. So as you go through, we had a p-value of 0. Okay. Is the p-value statistically significant? That just means you have a small p-value, less than 0.5. So we'd say yes. Okay. We can use the p-value to evaluate the strength of evidence. Okay. And so when you look at p-values, if you have a small p-value, less than 0.05, then that means you do have evidence against the null, and you have evidence for the alternative. So we would say we do have evidence. Okay. And then it's going to talk about how the p-value is the most common way that we decide if we have evidence against the null or not. Okay. But we can also actually do our standardized statistics. So it's just a different way to do significance tests. Not better, not worse, just a different way. Okay. So what we're going to do is we come over here and we click summarize statistics, and it will tell you the mean and SD. These are the mean and SD of all the different sample proportions that we could have gotten, or that we did get in our simulation. So the mean for all of these is 0.499. So I would just type in 0.499. Okay. And also, like, why does it make sense that this mean is close to 0.5? Well, 0.5 is the number we put in for our population proportion, or our probability of heads is 0.5. So we know, okay, or it would make sense, right? Like if our population proportion is 0.5 and I draw out a bunch of samples, it makes sense that I would get sample proportions that are also close to 0.5. And when we learn about essential limit theorem, we'll learn that this happens every time. Okay, but it's just always going to be centered at whatever number you put in for your population proportion. All your sample proportions will be centered at that same value. Okay, now report the standard SD, or standard deviation of the simulated statistics. So the SD of all these possible sample statistics was 0.061. And all I have to do is just read it off of that simulation. And later we'll learn where this number comes from and why that number makes sense as well. Okay, what does the SD mean? So you can go to our class notes where it talks about what does the standard deviation mean. But the standard deviation is our typical distance that the values are from the center. So you could say for all these different sample proportions, the average distance they are from the center is about 0.061. Okay, it's just a way of telling you how far your data is from the center. Okay. And then from that, once we know our mean and our standard deviation, we can calculate our z-value, our standardized statistic. Okay, so it says here our z equals our observed statistic. So our observed statistic is 0.8182 minus our mean of our null distribution, or we said it should be like 0.5. You can do your hypothesis because they'll be about the same, just rounding because you're simulating. So you can minus 0.5 or you can minus that 0.499. and then you divide by the standard deviation of the null distribution. And whatever you get, that's your standardized statistic Z.